So hello guys, this is Siddharth Singh Bhadoria. So today we are currently starting a lecture on software testing. So it will be an introductory lecture. So basically it will comply of, like, in introduction we will talk about like why do we use software testing and what is the difference between verification and validation, and we will also talk about limitations and where we apply all these things. So let's just start with the lecture. So first of all, I would like to tell you about why do we do software testing? What is the use of testing? So basically, testing is the process of executing a program with the intent of finding faults or errors within the software. So like whenever we are making any software, like any application or program, so there may be some errors. So by the process of testing, we are finding the possible errors. We are writing some test cases so that we can actually find that where is the error in our software. So first part, it is the process of demonstrating that errors are not present in our software. So basically it is the goal of software testing where we are actually wanting that the software we are making, that is free of any kind of error. And its purpose is to show that a program or a software that performs its intended function correctly. Like whenever we are making any software, we are making it with some idea. We actually want it to perform something. So if it is doing those things correctly, so that is all what we want from our software. And it is the process via which we make sure that our program or software exactly does what it is supposed to do. Now we'll move to next. So goals of software testing. Its goal is to find the critical situations. Like if we are writing any program, then at some point our program or software may give some unexpected output. So by testing, we are finding that difficult or unassumable. It's not unassumable, it's like that situation which is creating some error. So that is what we are trying to find it out. So it is to find out every critical situation so that our program doesn't get failed. Like whenever we will find any that situation, we will try to remove that situation. So but like if we are not able to remove that fault, like if we are able to remove that fault, that is good. But if it is not possible to remove that fault, we will give a warning that this case is not included. Let's take an example. We are writing in code for finding the minimal value in an array. So if so one condition is that if the array we are sending is of size 0, like no element is sent, we will simply show an error that yeah, it is having no value, so we are not able to find any minimal value. Let's take an example. Like we are giving, like all our test cases are in ascending order. So what we did, we are just giving an output of the first element of the array. So as our test cases are skewed, that is they are already in ascending order, so that is working well for all the arrays which are sorted ascending order. But what if array is not sorted? At that point it can create error. So this is why we have to make our test cases in such a way that they are not actually skewed. We have to jumble them up. Every possible situations need to be jumbled. So we are actually getting the right thing, and every possible error, every possible, like, that where the error can occur, we have to find it out at how it is creating an error for the system. We will move to next. So now we are basically differentiating between what are the difference between programs and software. So programs are basically subset of software. They're just code. Program is nothing but a combination of source code and object code. While software, it comprises of programs plus documentation manuals plus operating procedure manuals. So here program is simply a source code and object code, just a combination of this thing. For documentation manual, that basically contain documents of software requirement and their specification, their DFDs like data flow diagrams, their use case diagrams, their software design documents like ER diagram, class diagram, sequence diagram, and something, all details of these things. They are basically documentation manuals. And now how we are going to operate that. So for the operating procedure manuals, that will basically contain that how beginners guide, like how it is going to install it or doing something like this. its terminology, its menu, its installation guide, its maintenance guide. So this is all about the operating procedure manuals. So when we combine all these three things, that is operating procedure manuals, documentation manuals, and program, that combination is called as software. So now our thing is verification and validation. So verification is the process of evaluating the system or component to determine whether the products of a given development phase satisfy the conditions imposed at the start of that phase. So basically, verification, it starts at very early phases of the software development, and it checks or review the document generated after the completion of each phase. In verification, we are just looking into the reviewing the requirement document, the document manual or report we're creating. We are just checking those documents. We're not executing anything. So this is a manual testing. It just involves, we are just looking from our like eyes, we're just reading it out, we're just checking it that whether any report or document or anything that is creating error. So we are just looking at the document at the end of each phase, and it is being tested, like it is being tested at the starting of every development phase. So this is, we do with verification. But in validation, there is a difference between verification and validation. In validation, when our software is ready, at that point we actually execute it. So it is dynamic testing, and it is requires the computer for execution of the program. So we are running it, and then we are finding that what is the error, and if there is an error, we remove that error, we debug that error, we find out that where the error is occurring, and we correct that. So that is for the validation. Like after finding error, we are settling it. That is what we are doing for validation. But in verification, like after every, in the starting of every development phase, like this was for verification. So in the verification, we are checking the document that is being over there. So that was manual testing. But in validation, we are actually running our software code or our program, that it is giving right output or wrong output. So testing is basically combination of verification and validation, and both are really essential and complementary activities for software testing. So now there are some limitations in software testing. So basically, we need something very vast before delivering our product. We want to test everything before giving the software to the customers, and that everything is really, really very vast, because we have to put these three things in mind. Like we have to execute every statement of the program, we have to execute every true and false condition, we have to execute every condition of a decision node, we have to execute every possible path, we have to execute the program with all valid inputs, we have to execute the program with all invalid inputs. So these things are really very impossible to do for us to do. Is it really possible? Like there are a lot of things, so it is impossible for us to do this. So that is why it is limited. Like we cannot completely test our software. This is the limitations in testing. Now, how we can approach, if we really want to do testing, then how we can approach for our testing? So basically, the model which complies, which really works, that is the V-shaped software lifecycle model. It is basically a modified form of the waterfall model with a special focus on testing activity. In waterfall model, development part consists of four phases. Like first phase is requirement analysis and specification, where we tell about that what is the software requirement and what is the specification. And at the second phase, we do high level design. At the third phase, the detailed design, and then at the fourth phase, we have implementation. So our idea is, like in first phase, what we'll do, we are doing development as well as we are preparing test cases and the plan for the test cases parallelly. Like we have team for development, we have team for testing. Like when we are in the first phase, we are doing requirement analysis and the specification. Like when we're developing that first phase, at the same point, a testing team, the testing team is developing test cases for requirement analysis and the specification part. When we are doing high level design, that is the second phase of development cycle, at the same point we are creating a test cases for second phase. When we are doing detailed design, at the same time our test team is developing test cases for that part. So basically, our real aim is to write test cases and test plans parallel with the development phase, and which will be at the end executed. So this is, see, the acceptance test case. This is what our parallel thing. The acceptance test case design, which is linked with the requirement analysis and specification. So requirement analysis and specification was the first phase of development cycle. So that is parallel to the acceptance test cases design. So we at that, like both these things are designed together, one by the testing team and one by the development team. And for phase second, system test case design, their planning activities are designed along with the high level design phases. So development part and testing parts are going hand by hand, they're going parallelly. And then the third unit and integration test, that was parallel to the third phase, like the which was detailed designing phase. So development team is working on detailed designing phases, and the testing team is working on unit and integration test case design. And after that, the fourth phase, we implement all these things in development phase. And once implementation is done, like our all test cases are also prepared, our development is done. So after implementing, we will simply execute everything. So we will implement, we will after implementing, we will execute all these things, and then we will observe the responses of the outcome of the execution. So this will improve the quality of how we are preparing our software. So some testings, like which are done in this. So the first is acceptance testing. In acceptance testing, like when a customer is going to purchase, like I have made given a developer some software made. So while getting that back, like when they were made, so I will go and I have some predefined test cases for me. I will test it on those test cases. Once they run on that test cases correctly, only then I will take that from the developer side. And if some errors are coming, then they will simply fix it, and then we will take. And other testing is alpha testing. So in alpha testing, the it is done on the developer side, like the site which is present near the developer. So that is done under supervision, like that is done in a controlled environment. The developer is having a permanent look on that, like how the customer is giving the test cases. So developer's eye is already on in the case of alpha testing. But in beta testing, what we do, like it is open for the customers. So customers are entering anything. So we are exactly getting that what error can actually come, and we are getting the errors from the customer, and that too of any cost. So these are by beta testing are the most advantageous, because company is getting the feedback from the side of the customer, and without like customers are not made so to make payment, because that is not activated, like the payment part is not activated. So customers are they are directly giving various feedbacks, they're directly telling that we are getting problem from this side. So in beta testing, this is the real thing. So in this, the site is open for the real life environment where many potential customers are inputting their things, and then if there is any failure, then they directly tell it to the company that yeah, this is where we failed. So beta testing is always more preferable than alpha testing. Some terms which are related to our introduction section, we have quality assurance. So quality assurance is a defect prevention technique. So if it is there in defect, it will make sure that from the next time we, so in quality assurance, we are making sure a defect is not occurring. We are preventing any defect to occur. We concentrate on the process of software development. So we make sure we start from a very sequential manner. We make sure of any we make sure to make it of very good quality. Standard techniques are used. So that is what we do for quality assurance. In quality control, like if any defect is occurred, so we are correcting that. We are improving the quality at the end. We're getting the software. After that, we are making sure that no error is occurring. If any error is occurring, we are correcting that. So we are controlling the quality at the end. That is the quality control. So quality control is basically correction technique, while quality assurance is a defect prevention technique. So static testing refers to the testing activities without executing the source code. In static testing, what we do, we simply look into the walk through the reviews, a document, like whatever the document we got, like the documentation manuals, we just go through that. We're not actually executing the programming. That is static testing. In dynamic testing, that refers to in dynamic testing, we actually execute the source code, and then we see that how it performs and how its output are varying or giving different outputs. That is dynamic testing. So some common terms, like a fault is basically error in data flow diagram, ER diagram, or in any mode of expression. Like if you're writing anything, then at that, but if any error is occurring, that is a fault. But if fault is in the source code, it is called as a bug. And failure occurs when we actually execute the program having fault or bug. So like if we are running a program that is having fault or bug, at that point failure will occur. That will not run, that is a failure. And debugging is the process of removing that fault. So that is debugging. This all thing is related to the chapter first of our software testing. That is the introductory part. And this video is basically made keeping in mind the ideology of the DTU students, or the students of, like the students were having software testing in the syllabus. So this video is made for all the students of software testing. Have a look and go and keep and subscribe channel. Thank you.